All right, pre-cal. Welcome to Geometric Sequences and Series. Today we're going to be focusing on geometric sequences. And a geometric sequence, often described as AN, differs from an arithmetic sequence in that successive or consecutive terms are found by a common ratio denoted R rather than a common difference. Okay, so what this means is a geometric sequence is something like 2, 6, 18, 54. Okay. Why? Because 2 is just 2. 2 to 6 is 2 times 3. 6 to 18 is 6 times 3. And 18 to 54, if my pen will work, is times 3 as well. Okay. So what we do is we say R is 3. And essentially, if you're multiplying to get to the next term, it's geometric. If you're adding, it's arithmetic. That's all we're saying. Okay. So with that, it says find the next 3 terms in the sequence. We have, didn't mean to do that, but 18, we just said 18 times 3 is 54, and then we have 162. So this is a little painful to do by hand. So what we can do is we can go to a calculator. Let's see if it'll show up here. Yes. Okay, so we'll go to the calculator. What I'm going to actually do is I'm going to go under y equals, and I'm going to type in, and you could also do this on Desmos. I'm going to type in 18 parentheses 3 close parentheses caret x. Now, what am I actually saying? Well, what I'm saying is I've come to realize that 18 times 3 is 54, right? So if that's 54, then 18 times 3 times another 3 is 162. But what is 18 times 3 times another 3? That's the same thing as 18 times 3 squared. So next term would be 18 times 3 cubed, so on and so forth. So if I say x is what I'm looking for when I hit second table, it'll just tell me. It'll say, hey, 162 times 3 is 486. Let me do this. Okay. And then it'll say times another 3 will give me 1458. And times another 3 is 4374. And if you don't believe me, you can just keep multiplying by 3 and you'll see you'll get the same thing. Okay? So again, all we're doing is we're stressing that when we're a sequence is when you list. If you're multiplying to get to the next terms, it's a geometric, and you solve accordingly. All right, let's see what's happening here. Example 2. Let me pull this over here. Find the common ratio of the geometric sequence with A1, which we know is the first term, is 3, and A2 as 6. List the first 5, write the sequence as a recursive function, and graph the function. Okay, so I'm not too concerned about graphing. I'm more concerned about the other part. So first off, let's list the first 5 terms. So if the first one is 3, the next one is 6. We can see that what we're doing is we're multiplying by 2. So you could just keep multiplying by 2, but what I'm going to do is I'm going to say it's 3 to, I'm going to say y equals 3, 2 to the x. Because then I can just look at a table and I have all my wonderful values. So let me move this over here so I can do that. Let's go in here and just clear it. And we'll go 3 to the x. And we'll go under shift graph and we'll look under table, and we can see that 3 times 2 ones gives me 6. So the next one times another 2 would give me 12, times another 2 would give me 24, times another 2 would give me 48. Oh, we gotta go to fifth. Sorry, my bad. Times another 2 is 96, and that is the fifth term. So we have A1, A2, A3, A4, A5. Looks like actually I went a little further. Okay, I went a little further. This is A5. So this is going to be A6. It's all good. Doesn't really matter. Okay, so it's nice to just be able to list it on the calculator. If I wanted to see the graph, I'm not too concerned about the graph, but it would look like this. And this makes sense because, right, this equation is, we've seen before, this is exponential, right? And we can see, and of course it has to be exponential because you're multiplying multiple times, right? That's what exponential means. Okay. All right. Now, if I wanted to write this as a recursive, remember, recursive just means that we're saying, what do you do to the next term? Well, that would just mean that we have 2an minus 1 equals an, where a1 is 3. How come? Because you're multiplying, right? So whatever you're multiplying by, in this case 2, would have to be in front. And look, if you don't believe me, 3 times 2 is 6. 6 times 2 is 12. So again, what we're saying is, it's kind of like a endless loop here, right? You use the previous term, in this case 3, to find the second term, which becomes 6. Then you plug in 6 to find the next term, which is 12, and then so on and so forth. So I hope that that's clear. Let's just keep going. Consider that confirms, the sequence defined by an3 times an minus 1 with a16 can be expressed by listing the first 5 terms. Okay, so what this is saying, this is very similar to what we just did, but if I say a1, that's 6 times 3 to the 1 minus 1. Now, I can just go under y equals and type that in, but I'm just going to do it by hand for now because its numbers aren't too big. So the first one's going to be this is just 6 times 3 to the 0. We know 3 to the 0 is 1 times 6 is 6. We're doing 3 to the 0 first, by the way, because of PEMDAS. Multiplication comes before, exponents come before multiplication, rather. So this gives me 6, and then we'll do a2, which is 6 times 3 to the 2 minus 1, which is 6 times 3 to the 1, which is going to be 18. And we can see that this is an old friend, 6 times 3 to the 3 minus 1, which is going to be 6 times 3 squared. So that's 9 times 6, which is 54. A to the 4 is 6 times 3 to the 4 minus 1, makes 3 to the third, which is just times another 3, so that's what, 12, 162. And a to the fifth, 6 times 3 to the 5 minus 1, which is 6 times, now I'm just going to say 3 to the fourth is 81, so what's 81 times 6? That's a 6, and 8 times 6 is 48, 486. So these numbers are actually doing the same thing over and over again, right? That's right here. So 486, right? Was the last one? Yep. Okay. So there you have it. And that makes sense, again, because, well, I mean, really, this is what I wrote. It's the same thing as this, except with a 3 instead of a 2, right? And this also illustrates what the actual geometric sequence formula is. And then, so the explicit form is an equals a1 times r to the n minus 1. Because all you're doing is each time you're just multiplying by another 3, right? So that's the same thing as raising to an exponent. Okay, so this is the geometric sequence formula. And now we'll probably do some things that'll get a little more interesting. Right, the explicit form of a geometric sequence where the first 2 terms are 3 and negative 3/4, find the first 5 terms. So we know we have 3, and then we get negative 3/4. So to be very clear here, what you do is, if you're asked to figure out what the formula is, we know what we're doing to get here. We're taking 3, we're multiplying by some value. Now what's important in math is when you don't know what that some value is, you just put in a variable, in this case r. So we have 3r equals negative 3/4, and then we solve for 3. Whenever I play with fractions, I like to multiply by a fraction. So instead of dividing by 3, I'm going to multiply by 1/3. I just think it's clear on the other side. This gives me negative 1/4, which is r. So I'm multiplying r by negative 1/4, which is pretty obvious if you think about it, because 3 times negative 1/4 is just negative 3/4. Okay. So what does that tell me? Well, remember my formula is an equals a1 r to the n minus 1. So if that's the case, well, we know the first term is given, which is 3. We just calculated r to be negative 1/4, which I'll put in parentheses, n minus 1 equals an. Okay. Then it says list the next 5 terms. I'm sorry, find the first 5 terms. So the first one's 3. So a1 is 3. a2 is negative 3/4. And you have 2 options. We know we're multiplying by negative 1/4. So I can do this by hand and just keep in my head thinking about what does multiplying by 1/4 mean. Or you can type it in the calculator. I'm actually going to do it by hand because if I do it in the calculator, it's going to be a decimal, and I think it makes more sense as a fraction. So I'm multiplying by 1/4. The bottom is just 4 times 4, which is 16. Negative times negative is a positive. So notice the signs will alternate between negative and positive. Next one is 4, and that will be times another 4. So let's write that again. Brain needs to work a little better. 64. This one's going to be negative, right? And then a to the 5th means we're going to do, now I don't actually know what 64 times 4 is. I should know, but I don't. Don't judge me. Let's get out of here. So second exit. Second exit. Okay. What did I say? 64 times 4. I'll probably do that in my head. I did know that was 256. Forgive me, I'm doing this late. And then this one needs to be positive. So there we have it. There's your first 5 terms. Okay. All right. This is the more interesting question. The third and the 6th term of a geometric sequence are 80 and negative 5,120. 5120. Find the explicit form of the sequence. Okay, so when the first time you're doing this, and if the numbers aren't that big, you of course can just write it out just to visualize what's going on. So I'm just going to write this out to the 6. I'm kind of wanting to put a to the whatever on top, but I want to keep that at the bottom. Okay, so this is just a nice little way of kind of numbering things out to visually represent what's going on. In the future, we won't need to do this, but when you first start, it's nice. 80 is the third. The 6 is negative 5120. So what are we doing? Well, what we're doing is to get to the next term, you're just multiplying by r. So the next time is going to be times another r. And the third time, it'll be negative 5120 equals 80r cubed. Okay, the third one would be cubed. But really, the difference between these 6 and 3 is 3, so that would be the exponent. So now all I have to do is solve, so divide by 80. Don't judge me, I'm going to type this into the calculator. So it's really just 512 divided by 8, but negative. So it looks like I'm multiplying by 6.5 when it's r cubed, so then we'll take the cubed root of both sides. That'll get rid of the r cubed. And so we'll do, now when I do this, if I'm doing it on the calculator, what I actually like to do, I don't actually worry too much about the negative thing, because I know that if you take the odd root of something, it's going to be, and it's negative, the argument's negative, and the whole thing will become negative. What I do like to do is I like to write it as just 1/3. I don't have to, I can hit math, and if you look at number 4, it's there, or I could have hit the 3 first and then done 5, and that would have worked as well, but I just prefer I think it's easy enough to do 1 divided by 3, and let's see what happened. I don't understand why it's not working. Sometimes this thing does not work right. Not sure what's going on, so never mind. We'll do 4. Maybe because of the negative, I don't know, negative 6.5. Let's see what happens when I do that. Okay, so this gives me the R value to be negative 1.866. Let's see here, if I hit math, I'm curious. Enter, enter. Yeah, it's not going to convert it. Okay, so in any case, R is not a very pretty number. That's okay. If I want to find the first term, we can do the same process in reverse. I see what the problem is. It's not negative 6.5. This is incorrect. I didn't type it in right. 50, let's do it again. 5120 divided by 80 is 64. And then the cube root of 64 is going to be negative 64 is going to be negative 4. That's better. Okay, so there's 2 ways of doing this. If I list it as such, I can always just keep, if I'm multiplying going forward, that means I'm dividing going backwards. So you divide it by 4 is negative 20, and this will become 5. You can check it by multiplying. 5 times negative 4 is negative 20. Negative 20 times negative 4 is 80. Boom. The other way, of course, is you can write it as a formula. Do some new colors here. You can say, so if it's an equals a1 r to the n minus 1, you know, the third is 80. You don't actually have to even use that. You can use the negative 5120, but that's not going to be as fun. So I'll put an r as negative 4. And I want to write n, but it's really not n. We know it's the third term, so 3 minus 1. This give me 80 equals a1 to the negative 4 squared, which should make sense, right? Because you're jumping 2 times, right? And so it's going to be 80 equals a1 to the negative 16. And it better be that when I divide by negative 16, I get negative 5, because now, this is positive 16. I am so full of mistakes, but it's okay. It's good, actually, that I make mistakes, because these are probably the mistakes that some of y'all are making, or may make in the future, right? Negative 4 squared is positive 16, so I should be getting a positive 5, okay? So there's a couple ways of doing this. Obviously, if the numbers are not the third and sixth, but like 100 and 150th or something like that, no es bueno, right? It's going to not be very fun to do this. But by hand, this is really all that there is to it. And this really is all there. Oh, wait, no, one more question. Find the 10th term in the sequence, all right? So you can see clearly here that your r is 1/2. So if it's an equals a1 r to the n minus 1. And I always like writing this because it helps you to memorize the formula. We know this to be the case, right? The first term is 1, r is 1/2. Now if they're saying the 10th, right, then I can say a 10 is 1 times 1/2 to the 10 minus 1. And for funsies, I will just type this into the calculator and double check to make sure that I type it in correctly, because I struggle with that. Now I'm just going to type in 9, and it's going to give me this. And what I may do is just hit math, and we'll see what happens. Enter, enter, so it can give me this, right? And you could have also just said, look, I want 2 to the 9th, right? Because the denominator is the only thing, and you see that's 5/12 as well. Okay, so this is that's the answer to this part. And obviously r is 1/2. Okay, let me check. All right, now we're done. So hopefully that makes sense. If there's any issues, please make some, you can always post some comments, or email me or reach out to me in any means possible, and I will try to re-explain these. But hopefully that makes sense, and you guys are doing a good job, and I will find you in the next math video or in class. Or online, I guess. All right. Y'all be good. Peace out. Bye-bye.